Okay, everybody, we can kick this off with the idea of other people being able to join us later. We are actually recording this session as it's a great opportunity to be able to share it beyond. We're very lucky to have a fantastic subject today after some amazing Splunkterns joining us. And we were so excited about the projects they put together. We said we couldn't keep it to ourselves. We needed to share with the wider community. So thank you very much today for taking the time to join us. Just before we kick off, I wanted to introduce the various panelists that you'd see on site here. All representing your local area, depending on where you're based yourself. In this virtual world, it's great that we can all come together for the one session, but you can reach out there to anybody that you see in the panelist team from this list to your left, and you're able to ask any questions. On the topic of questions, please move those questions to the Q&A panel. As the Splunkterns are going through each of their presentations, as you start thinking of a question, please pop it inside there and the Splunkterns will go and answer those questions afterwards. As for the chat, please use the chat for any communications you want to do with the broader community, or if you've got ideas or thoughts that you want to be able to add and share. So very importantly, please use the QA and don't worry about getting the answers straight away. We'll have an open session as well at the very end to be able to address anything outstanding. Also worth calling out, we've got the Boss of the SOC coming up, and it's really important to note here that tomorrow is the last day to register. So if you haven't done so already, please jump on fairly quickly because it's going to be an outstanding session. They're expecting 1,000+ participants with 500 teams, which is just crazy. You can register up to 4 in a team. So as I said, make sure to try and have a look at that. It's going to be awesome. Of course, we do have .conf as well coming up, which is our biggest user event globally all over the year. This time it's gone virtual, which is fantastic. And I'm delighted to say that attendance is free, but you probably need to pay for your own travel and board. It's just 2 days, so it's going to be a fantastic opportunity for you to be able to join and listen to all the great stories, not just from Splunk and its latest announcements, but what other customers and awesome partners are doing with the platform as well. So it's a fantastic event. If you haven't been there before, no excuse not to miss it this time. And also want to call out the awesome workshop Wednesdays that we're running. There's a site link here that you can go to and connect to. We will be sharing this deck along with all the presentations afterwards for your convenience. These are workshops that are run every Wednesday, spread across the likes of IT ops, security, machine learning, so on and so forth. Great opportunities to get involved whether you're a beginner, intermediate, or advanced user. So please take advantage of this free training that's available. And with that, I really want to take the opportunity to be able to introduce our fearless sales engineer director, and also the front seat driver when it comes to the Splunkturn program here in ANZ, Mr. Neil Gow. So at that, Neil, can I please introduce yourself?
That's great. No, thanks very much. For those who don't know, this is Neil Gow. So I'm based in Sydney, operating obviously virtually, being with Splunk now, just tipped over into my 5th year, and have the privilege of looking after and running the intern program in ANZ. We're just entering, closing out our 3rd year of the program. It's something I'm really passionate about, and as they've said, just the enthusiasm and the input and the technical adeptness of the interns have produced some really interesting work. And I just want to sort of share a little bit of a backstory around what the internship program is and what we actually sort of asked them to do in there. So there's a bit of an open statement around that. Can you advance me, Lev? So,
yeah.
That's it.
Yeah.
Yeah, that's great. So really, what is an internship at Splunk, as we talked about? So they join part of the ANZ sales engineering team, which is why we are hosting them all today on that, and all the mentors will be part of it, all come from the ANZ team, sales engineering team on that. And it's something we've sort of taken. We do run these programs globally, but we've pretty much sort of taken it and run with it and given it our own sort of Aussie spin around how we want to run the program and integrate around that. It's, as I said, it's now closing out into the 3rd year, and we're very hopeful, and we will sort of continue. And we, as I'll show you on the timeline, we're about to start off the process to identify and select and try and basically get a next year's FY22 interns that will join us for the upcoming program itself. What we try and do is embed them across the teams itself. So traditionally, when we first started, we only had a couple of interns. We put them in Sydney and Melbourne, but we've now, for this year, sort of expanded the program, and they join us in Sydney, Melbourne, Brisbane, and Canberra. And we have representatives, 3 of those 4 geographies, as you will find out on the call today. We really do, and typically around that is a lot of them, sort of Splunk is used, for those who are aware, from a sort of commercial business perspective in virtually every single sort of TAFE and or university in Australia and New Zealand. And what we've tried to do is build on that collaboration and develop and strengthen relationships with those to encourage and promote the internship program, to support the courses that they do, but also to a certain degree to help the interns acquire skills that they wouldn't necessarily be exposed to as part of a uni program, and help facilitate them into their first job, whatever that is. And again, it's a flexible or full-time, part-time commitment. So our interns today actually are doing it part-time. So half the week they're at uni completing their work, and half the week they are with us. So therefore it's sort of a lapse time of 6 months. So they all started with great fanfare in February and have been working collaboratively through 6 months. And it's really a tribute to what they bring to the organization, that obviously the world got turned on its head earlier on in the year, through COVID. So it's a real credit to how they've adapted and maintained and contributed greatly to the program itself, which you will shortly see as we go through. So why do it in the first place? That's what the internship is really about. Gives them the opportunity to understand what Splunk is, but not only, but also how the individuals yourself are actually using Splunk in its own right. And it's all around, why it's been applied, but most importantly, the value that the application Splunk is bringing to the likes to our users, such as yourselves. We also want to concentrate and help them develop transferable skills to present product solutions, customer engagement. So those transferable skills will be sort of discovery, presentation, but also issues creation as well, or objection handling. So these are all elements that are core to our role as sales engineers as well, but we also believe they're of great use and are transferable to whichever post internship career and development individuals want to do. Obviously, we want to improve their technical skills related to Splunk. The vast majority of interns join us predominantly having heard of Splunk, but not really having any hands on experience. So we really take them from zero all the way up to the point where they can develop the projects that you actually see this afternoon. So again, it's a credit to their, what they bring to the program as well, that they're able to start from virtually zero understanding of Splunk to developing a really interesting array of projects of quite incredible complexity and discipline around that. What you're seeing is we want them to do a custom project, because it's really for us the genesis and bringing together the business acumen elements, the soft skill development, and the technical training that we actually put individuals through. They're working alongside us and really get exposed to every aspect, or as much as we can do, from sales and engineering. And most importantly as well is to have fun. It's a bit of a hallmark, but we also want to expose them to what we believe is a great working culture, that also raise opportunities where they are, that they can join us, but also we can potentially facilitate, identify, if they want to continue their career as Splunk, they can join our partner or our customer ecosystem around that. So what does it involve? I'll build this one out. So we've said we've got on the left-hand side all the classic work of as a sales engineer. Then as much as that, we're also trying to develop and help with personal development, of which the project is a key element around that. But just really understand how Splunk operates, where it fits within the commercial ecosystems that exist within your customer bases, as we're sharing this afternoon. So if you can say, so how do they basically sign up? So this is it. So this is the program that we'll be going through for next year. So we typically run open days. This year it will be a virtual open day. We then go to applications, and then through an interview process, we would go through. So to give you an idea, for the 5 interns here, we had nearly 350 applications across the university on there, and we were able to whittle down and offer those 5, which we were very grateful they accepted. So the whole idea is that as they come through, we hopefully, although not always, try and get the offers out before the end of the year. but with the aim that we kick off or kickstart the internship program in the February. And it starts with a intensive sort of tech boot camp and an induction, which sort of kickstarts the technical. And then we overlay week by week a combination of deep dive events, field events, marketing. There's a whole series of events, as we said, to the whole theory that exposing them all to as much as sales engineering and to really sort of identify and promote sales engineering as a career of choice. We're here in a little over, so typically the program of 6 months will finish, but where possible, we try and extend the internship as well, all the way through, and then see particularly what opportunities they are to join us. So we've had in previous years a number of interns that have gone to partners or to customers, or have actually joined the ranks of the sales engineering team, or have gone to other areas of the business. You know, one of last year's interns is actually a site reliability engineer now as well with Splunk as well. So it's not just that, we want to bring them in, sort of promote them, help them with understanding, but also offer them other potential careers that sort of fits with their desires. So I think from that perspective, happy to hand back to you, Dave, to actually sort of kick this off. Thanks very much.
Thank you. So yes, absolutely. And I'm glad you said have fun, Neil, because our Splunkterns certainly bring fun and curiosity. And that curiosity translates into a lot of energy. And that energy results in these awesome projects that you see here today. So the Splunkterns have been amazing to us over the years, this year being no different. And to kick it off today, I'd really like to, I have a lot of privilege to be able to introduce Edlin, who is a fourth-year student here in University of New South Wales, studying mechatronics and computer science. So this girl is not only an excellent engineer, but she's also a rock climbing superstar, one of the real spider women who's no doubt going to be dominating the likes of Australian Ninja Warrior in the years to come. That is, of course, if she can get over her obsession with fried chicken. So introducing Edlin, and Edlin, I'm passing control now to yourself.
Thanks, Dave. Is the screen?
Yeah.
Oh, okay, there we go. So the project I chose was based off my personal experience with this problem, where I sat on a train and was like 40 minutes late to my exam because of a signal problem. And this isn't the first time where I've been stuck on a train or a platform that caused me to be late to my appointments. So usually I read articles to find out what's the cause of the delay and often question myself why these issues are happening in the first place. And with Splunk and this project, this led me to the problem statement of how can we gain insight into day-to-day train operations to reduce time and cost for transport in predicting and resolving critical incidents. So I thought this question was important to ask because it would help transport save time and money in resolving critical incidents, provide transparent insight into the day-to-day operations to help guide business and logistical decisions, as well as improve the overall user experience of commuters. So the questions I asked myself to help guide my Splunk solution consisted of like, how long does it currently take to react to unscheduled train issues? And how long on average does it take for engineers to recognize a problem is about to occur? As well as how many reactive alerts do operation engineers get per day, and how many of these alerts are actually useful and critical? And is there a way to effectively filter and prioritize the severity of these alerts? And how long does it take for them to fix these alerts? So that comes with my solution, assuming that we are Splunking data from existing IoT devices and sensors. I created example data using EventGen, an app in Splunk, in which was based off research of current IoT devices and sensors in which help trains monitor and analyze their maintenance issues. So the train network has thousands and thousands of sensors, equipment, and devices running across the whole train network, monitoring different areas such as train maintenance, rail maintenance, signal maintenance, security, and more. Oh, no, I need to go back to the previous slide. And there's currently no existing solution out there on the market that can weave data from across the board into a meaningful story into one single dashboard other than Splunk. So I created 4 dashboards in which cover real-time delays, train maintenance and availability, security monitoring, and station and train executive health. So onto my demo now. So this is the train delays overview dashboard, and it is showing information about real-time train delays. I've gotten this information off from the Open Data Source Hub from Transport New South Wales, where there is a free public API, which you can use in a Splunk app called Real-Time GTFS. And in this dashboard, these panels show the real-time average delay of the train routes. And as we can see here, we have a route and the given average delay times. And if you click on one of these routes, you get all the different trips that are currently running and affecting this delay. So here we have some more information about all the delay time ranges, as well as the train delay by route over time. So this gives an indication of which train routes are performing well or not so well. So onto my next dashboard. This dashboard is about train maintenance. So this panel is regarding the predictive side of maintenance of detecting issues before they occur. As we can see here, for these different category of issues, these are the individual counts of the trains that are experiencing. So we can categorize these issues by severity of how critical it is to the train system. And if we click on this panel here, this will, that's a severity. And if we click on this panel here, this will take us to a more detailed overview of the stats. So here is a train service IDs, which are experiencing these range of issues. And one train might have several warnings. And we can categorize this by the train set as well as the perceived severity. So for example, for a given train set, we can click into it and see for the C set for the different types of issue description regarding brakes. So these are more detailed in describing what these issues actually are in the category of brakes. So we can see the given service ID of the train and the service IDs that are associated with these warnings, as well as the sensor IDs that are returning this value of the warning. And we can also see here, if we go down and do some drill downs into these values. So for example, if we click brakes and we can click on the brake temperature, for example, there's currently 12 counts of trains that have this warning with the brake's overall temperature. So if we see here, this is a given train ID, and we can actually get the real-time metric value of these readings given off by the sensor. And given a threshold, these can be pre-calculated or predefined, which can set what the warning range is. So for example, the normal range of the brake temperature should be like around 100 to 180 degrees. So anything past that, engineers should be alerted because it's reaching its critical stage. So my next dashboard. Oh. All right, there we go. Having problems with this. Some reasons. Okay, there we go. So this is a continuation of the train maintenance dashboard, where these panels are showing a reactive stage of train maintenance. So these panels is showing the number of failures by train. So the count of all the trains that have been decommissioned in the last 24 hours because of an unsuspecting issue that has occurred. And as you can see here, this is a number of available train units to the right that are actually ready to replace these trains. So we can also see a breakdown of the major issues by these train sets and the count of it and how many train sets are having these issues. So this information is helpful to see which train sets are performing well in areas and which aren't. The next panel is showing the mean time to repair for non-scheduled issues. And as we can see here, this is the mean time to repair for each issue. I assume that we could get these values from the engineers who use a clock in and clock out sheet to note down how long it approximately takes them to fix an issue. But later down the track in the future, this value could be retrieved by sensors that are monitoring these issues. So this panel is helpful in identifying how efficient transport is at fixing train issues and where they can improve upon. So here is a panel showing the progressive information about the maintenance train repair process. So here's a train set, and you can see here whether the train is currently in progress of being repaired or whether it's next to be repaired with components that have arrived, as well as if it's not been started yet and transport is still waiting on components and parts to arrive. I've also filtered out by like the issue and train set as well. I thought this might be interesting or helpful to see because perhaps it could be an aim of transport to try and get out of that red zone and achieve a just-in-time operation when it comes to their train repairs. And the next panel is showing the issue details and regarding the count and the average cost and the total accumulated cost. So for a given train, we can see the average cost it takes to repair it, as well as the total accumulated cost for every single train that has had issues across all time. So things that might affect these values might be the accumulation of the cost of equipment and the components that it took to repair these trains, as well as the salary of engineers who are working on repairing these trains. So my next dashboard is regarding security. And the security's dashboard's purpose is to ensure the security and safety of passengers and workers for the trains. So for example, this panel has a check of whether all the camera types are online or not. And if we scroll down, we can see at which stations these cameras are offline and how many. And if we click on this, we can get key information regarding the particular camera ID, the description of where it's located, how long it's been offline, and whether an alert has been sent or not. So if we scroll up now, this panel shows the incident count. And here we are assuming that there are gate cameras installed at every tap on, tap off gate. And we're able to detect whether someone has jumped the gate without tapping their card. So assuming that there's some kind of software available to detect how many incidents has occurred or whether it's been resolved by the train guards or not, if we click on this, we're able to see like a time chart of when these incidents occurred and during the time frame, as well as whether it's been resolved or not, depending on the different type of gates there are. So whether it be a pole or a turnstile. And here's just a map showing all the locations and the counts of where these incidents have occurred. My next panel assumes that there's some collaboration with the police and that there's facial recognition software in those CCTV cameras. And we're able to detect the offender, their perceived risk, last seen time, location, as well as exact camera ID that's been captured by and the camera location. So for example, we can click on it and we can see the last 15 minutes of where they've been up to, and you can even do it for like the last 7 days. Yeah, and that's where the whereabouts are. My next dashboard is an executive overview of a given station. So here's some information about the train performance, highlighting how on time the trains are. We also have some information about the station capacity and the number of scheduled delays, as well as some more information about the average crowd flow rate. So this is assuming that there's image recognition in those CCTV cameras. We're able to detect how fast a crowd is traveling through a station. And furthermore, we can see some metrics about how long it takes on average for the gates to open and close, and see the average train platform wait time. We're able to correspond this average value with those individual platforms in a visual map. And this is assuming that the map's in SVG format, where we're able to correlate the ID of an SVG map to a specific data source. And lastly, we also have the current train arrivals and train departures timetable. And my last dashboard is an executive overview of a given train, and we can see some key metrics. So for example, we can see its next stop in its journey, how far in its journey it's completed, a visual representation of where this train is currently on its current journey. And we can see how on time the train is as well, and the total number of passengers and the given train capacity. So here's a visual representation of how many passengers there are in each train carriage. And this is assuming it's in SVG format, where you can assign each carriage with a data source. And furthermore, we can see some other key metrics such as the average train speed, average start acceleration, average deceleration. And here's just a table warning for potential issues for that train, alerting the train conductor and engineers for further investigation. My next steps on my project could be further improved include using Splunk AR for on-field monitoring to help on-field engineers view real-time data that's streamed from these IoT devices and sensors, and being able to extend these use cases to not only train maintenance, but rails and signals, as well as energy analysis, but also on the wider scope, being able to extend the use case to different transportation services like buses or metro or ferry. And before I pass on to John, special thanks to Dave, Jeff, and the Splunkers from Transport New South Wales, Deloitte, and NTT who helped me with the feedback for my project. So thanks.
Thank you, Edelyn. And want to call out for any of the people looking at this that aren't familiar with some of those dashboard visualizations. She leveraged the likes of the beta new dashboard app And she actually wrote some fantastic blogs on how to be able to use that app along with the event gen. So check it out on LinkedIn. So very good, really great work. John or Dean?
Awesome. Thanks, Dave. I've been lucky enough to be the mentor for our Splunkturn up here in sunny Brisbane, and that's John Wang, who you're going to hear speak. In a short time here at Splunk, John has shown some incredible capabilities to learn some new products very quickly. So he's learned products like Splunk IT Service Intelligence, the InfoSec app for Splunk, and most importantly, Splunk Phantom, which you're going to see some of his handiwork that he's done between creating some pretty awesome playbooks and creating and editing some Phantom apps. Just a little bit of a funny story. I encourage you to put it through in the Q&A. Ask John about the risks of putting Docker instances on the public internet in AWS, and he might tell you how that worked out for him. Off to you, John.
Thanks, Dean. So this project was created intending to help Phantom to extend some of the use cases. So since Phantom is often positioned as a security orchestration automation response tool, and I think Phantom is such a powerful tool that can just do so much more than that. And with Phantom being a great automation response tool for Splunk, I think it's missing a lot of the market, potential market share in the IT market. So the solution that me and my mentor, Dean Jackson, came up to help drive Phantom into the IT market was to develop apps for commonly used tools or technologies in the IT industry. And the two technology we choose to develop an app for was Docker and MySQL database, which I'll be demonstrating the app later on. So I've also integrated Phantom with ITSI in this project and used some of the new actions from the new Phantom ITSI app to create an interesting demo and playbooks. So here we have the Docker app. So the Docker app is created utilizing the Docker remote API, and it supports 20 actions. So actions such as list container, stopper container, starter container, etc., etc. And then we have the MySQL app. So it is created utilizing the Python MySQL connector module. But it's a bit different to the Docker app, where the Docker app is an app that I've created from scratch, but the MySQL app is an existing app made by the Phantom community. And what I did was adding 2 additional actions to it, which will lock the database, that will lock the database for read only, and unlock the database, which is to remove that lock. Then we also have the ITSI app. Again, is an existing app made by the Phantom community. And I'm gonna use the add maintenance windows action and end maintenance window action in my playbook that I've created to demonstrate the capability of Docker app and MySQL app. So some of the technical givebacks. So the Docker app was submitted to the Phantom community and is currently in the reviewing process and should be available to download on the Phantom community soon. So with the MySQL app, is a bit of different. Like I said, is an existing app made in the Phantom community. So I've contacted Matt, who's a senior product manager, to incorporate some of the new actions for the SQL app. And you can download the app in both the links down below or over here once the apps are ready and finishing its review process. So now goes to the demo. So how the demo work is that I won't be demonstrating any of the actions from both apps due to time limitations. However, I will be demonstrating playbooks created using some of the actions from both the apps. Now let me explain my demo environment. So this is a glass table overview of my environment. So essentially I have 3 AWS EC2 instances. I have a front-end instance running front-end container, which is the React component of the web app. Then I have the backend instance running the backend container, which is the API gateway of the container. Then I have a database instance running my SQL database on it. And I've also bring some of the KPIs through the from the environment using apps such as SAI and DB Connect. So here you can see things such as the number of containers running in the backend, the memory usage of the backend container, and the number of containers running in the front end, as well as the memory usage of that container and the number of database exists in the MySQL database instance. So here's the tree view of my environment. So as you can see, the stock app is dependent on the front end, And the front end is dependent on the API, the front end container, and the front end host. And we have the API depending on the MySQL database, API host, API container, and SQL host. So most of the playbooks or demos that we're going to be doing today will be executing on the front end component of the web app. And here's a screenshot of the front end component of the web app. So now it goes to your first playbook. So in this playbook, we are demonstrating a real world scenario when a container uses too much memory, and we want to give that memory that container a memory limit using this playbook. So some of the actions I've utilized from the Docker app is the list container action that will essentially list all the available containers existing in the space. And we'll send that information to the user and let user decide which are the containers they want to take a snapshot of as a backup before we're making any adjustments to the running containers. And then we inspect that running container. Then we send the list of configurations in to the user and let user decide which are the configurations we want to change. And at the end, we will send the configuration to the Docker app using the update container action to send the configuration over. So we run the playbook in the debugger. So here you can see a prompt asking us whether we want to execute the playbook on the front end of the web app or the back end of the web app. So in this case, we're going to put 1 in the response section to execute this playbook on the front end component. Then we are required to take a snapshot of the container as a backup. So we enter the container ID and the name of the image, and we give it a tag as well. Then we get a confirmation saying that we have finished taking a snapshot of. And then we have required to send the configuration in. So if you can see here, we have sent the current memory limit of the container is currently set to 0. And we want to give that memory a limit. Oops. So here you can see that I've set memory swamp to -1. So whenever you want to give a container a memory limit in Docker, the memory swamp limit you set has to be larger than the memory limit. In this case, by setting memory swamp equals to -1, we are indicating that there is no limit for memory swamp. And also this value over here at the end, which is the memory limit we want to set, is the bytes. So all the measurements in Docker is measured as bytes. So this value at the end is equivalent to a gig of memory limit. So we get a confirmation saying that we have updated our containers successfully. So now if we go to our analyzer view, and we retrieve the container ID from the list container action that we have. And we copy the container ID. And we find our inspect container to check if we have updated our configuration. So if you scroll down, go to your data section, we can see the memory limit we previously set, as well as the memory swamp that we just set. So now we have the second playbook. So in this playbook, we bring ITSI into the game, and we are creating a scenario where we have to perform a service maintenance on a component. So you can see some of the actions I've realized in this playbook is the add maintenance window action from the ITSI app. And then we have the log database action from the MySQL app, which is the to log the database for read-only to prevent incorrect data written into the database while performing service maintenance. Then we have the playbook update container, which is the playbook that we previously demonstrated. And then at the end, we unlock the database, which is to remove that log. And at the end, we end the maintenance window to finish the playbook. So here we're creating a service maintenance window. We give it a name and we give it a duration as well for the service maintenance window. And then we get a confirmation with a service key indicating that we have successfully created our service maintenance window. Then we get a prompt asking us if we want to end the maintenance window. In this case, we haven't finished updating our container yet. So in this case, we'll ignore this prompt. So we go to execute the playbook on the front-end component of the web app. And then we paste the container in to take the snapshot of the container. We give it a name and we give it a tag of the image as well. And then we get a confirmation saying that we have successfully taken a snapshot of the container. And then just like what we did previously, we're going to give this, this container a memory limit. And press complete. And then we get a confirmation saying that we have updated our container successfully. So we press complete for this prompt. Now that we have finished all the necessary updating of a container, we can end the maintenance window. So now if we go to our ITSI app and refresh the page, we can see the service maintenance window that we just created, as well as the status of it being complete. Now, if we do the same thing, we want to retrieve the container ID from the list container action. Then we want to inspect the container to see if we have successfully updated the configuration of the container. And if we expand the data section, we can see the memory limit that we just previously set, as well as the memory swap. So where to from here? I think overall this app created more opportunity for Phantom in the IT market, and customers will definitely use this app as a response tool to IT alerts generated from the monitoring device. And I think I've also demonstrated some of the additional potentials for Phantom. And I've also created a YouTube tutorial on how to use this app and how to create a playbook with some of the actions from the app. And the videos are currently in the reviewing process and should be available to download soon. So if you want to know more about the app, you can contact me through my LinkedIn over here. And that's all. Thanks, guys.
Thank you, John. And that was fantastic. Not only is it a great project, but a fantastic contribution back into the user community around Splunk and Phantom that's going to help an awful lot of customers out there globally. So well done and a great accomplishment to you.
Thanks, Dave.
So very good. Next, I'd like to introduce our very own. So here we are with Yushin. And with Yushin is in his 4th year of doing his bachelor in computer science in University of New South Wales.
Third year.
Yeah. And he is focusing on cybersecurity as being his major. A little fun fact, he used to be part of the Royal Australian Air Force as an air combat officer, but since then he has taken his combat to ground, specializing in jiu-jitsu. So you want to be very careful when you're actually shaking hands with this guy, and he has a very hard time holding back. So passing over control to yourself, Yoshin.
Thanks, Dave.
1 second.
Right. Let's get straight into it. So my project was essentially to explore how we could utilize Splunk to monitor a trading platform and how we could ensure that the components of the platform are at optimal levels all the time. And in particular, we focused on the latency of the data sources coming into the infrastructure and the data sources leaving the infrastructure, aka the trades going out to the exchanges. And I just wanted to start off by going through some of the common challenges that may arise in a typical trading environment. Essentially, when markets are open, nothing less than 100% operational and 100% performance is acceptable, especially when the unit of measure we're talking about is in millions, if not tens of millions of dollars, and in nanoseconds. A single missed trade or a slowdown in a piece of application or infrastructure, even though it may seem trivial at the time, can mean a large loss of revenue. And as trading is massively time sensitive, latency is the single biggest factor that determines a trading team's success. And this is not only due to the fact that market conditions and prices are in constant flux, which implies a slow trade is essentially a failed trade. Low latency equals faster speeds, and that means a competitive edge over your competition. This is why it's absolutely crucial to be able to monitor the latency of the inbound and outbound data sources of a trading environment and ensure that it is within the acceptable limits. There's also another layer of complexity with the infrastructure and the applications being housed at the co-locations, which is something extra we need to monitor. And I'll go over what the co-locations can look like in a couple of slides. In addition to that, the data needs to be captured accurately to adhere to strict regulatory requirements as well. So in summary, trading is a highly stressful and a highly sensitive environment with a lot of moving parts, which all needs to be monitored to ensure that everything is always at peak performance levels. So here we have a case study. They are a leading financial organization. They are a well-known global investment bank, and they're essentially leveraging Splunk to monitor their key trading platforms and the fixed messages that are flowing through these platforms. They were able to use Splunk to pinpoint the failures quite quickly, and as you can see here, a single missed trade can result in the loss of tens of millions of dollars. And as mentioned previously, once you've lost the window of opportunity for that particular trade, that trade is gone forever. A typical workflow for a trade is highly complex and it can get blocked at times for a number of reasons. And in this case, this customer was able to use Splunk to decrease their investigation times by 66%, allowing them to salvage some of those trades that would have otherwise been blocked, ultimately minimizing loss. Here we've got a diagram to hopefully help illustrate what a co-location data center can look like. As mentioned previously, the co-location infrastructure needs to be housed as close as possible to the exchange to minimize latency. And oftentimes they'll be located within the exchange themselves. In the bank offices here, this is typically where you'll see the traders and the IT support teams live. And normally there'll be quite a bit of a distance between the bank offices and the exchanges. Now, obviously, this creates a level of complexity. As you can see here, they are multiple sources of market data vendors feeding their data into the trading infrastructure. And within this infrastructure, there are algorithms and trading platforms which will analyze the data to determine how and when the trades will be executed. The trades will then be sent off to the exchange. And if everything goes well, the trades will be approved, executed, and stamped with a timestamp, and returned back to the trading infrastructure, at which point the trade will continue on with its life cycle. So what we see here is that co-location is absolutely imperative, but it also adds a degree of complexity which all needs to be monitored. On our demo today, we'll be focused on the market data sources coming in from our vendors into our trading infrastructure, the orders going out, in particular the order throughput, the latency, and the bandwidth, and we'll also look at the fill ratios, which is essentially the number of successful versus unsuccessful trades, and the hardware statuses of the underlying infrastructure at the co-locations. So before we jump into the demo, I just wanted to emphasize again that trading operations are composed of highly sophisticated business operations, infrastructure, and applications. And they are essentially all required to operate in harmony at 100% performance levels all the time. And these highlighted boxes here in yellow are the areas that we'll be going over in the demo today. And hopefully by the end, they'll be a little bit clearer. Right, so let's jump into the demo.
So I'm going to stop sharing here, Yushin, and you can share your screen.
Yep, sounds good. All right. So essentially what we have here is an overview of the health and performance levels of the outbound data sources across each of the co-locations that are housed at the 4 different exchanges. And those exchanges being the New York Stock Exchange, NASDAQ, the London Stock Exchange, and the Shanghai Stock Exchange. And what we see at the top here, it's the bandwidth consumption or the pipe saturation between the trading infrastructure and the exchanges across our 4 locations. And what we normally want to see, and we want to monitor this because if the pipe saturation reaches over 100%, this can potentially start to spike the latency of the trades. And we want to see that the saturation isn't too far from what's expected. And everything here looks good, so we can scroll down. We also have just below the number of outgoing orders per second per exchange. And this is absolutely critical to monitor because trading firms will typically have a contract with the exchange, which stipulates the maximum number of orders they can send to the exchange per second. Hence, it's absolutely crucial to monitor this and ensure that this number doesn't cross the threshold. At the bottom here, we've also got the average round trip times of the trades across the exchanges. When a trade leaves the trading infrastructure, it'll get to the exchange, it gets acknowledged, and with that acknowledgement comes a timestamp, and that trade will be returned back to the trading infrastructure. And obviously, it's crucial to monitor this as a spike in trading latency can mean increase of latency, which can mean increase of trades failing and so on. So let's drill down and have a more detailed look. So what we have here is a more detailed view of the fill ratios across the exchanges. And the key take-home message here is that we're subscribed to receive market data sources from two different vendors, Bloomberg and Reuters. And you can see here that the trades being executed based off the data coming in from Reuters has a significantly higher failure rate than the trades being executed based off the data coming off Bloomberg. So if we come down a little bit, we can see that the derivatives and the equities trades are being executed based off the data coming from Bloomberg. There are some trades dipping, there are some fill ratios dipping below the 96% mark. But most of the trades, as you can see, are hovering around the 98 to the 100% mark, which is exactly what you would want to see. Down the bottom here, you can see that the Forex trades are being executed by the data coming from Reuters. And you can actually see that for NASDAQ and the New York Stock Exchange, there are periodic dips in the fill ratios, aka the number of successful trades versus unsuccessful trades. This is something that we don't want to see, and we'll investigate shortly. And you can see that for the London and the Shanghai Stock Exchange, the fill ratios are actually around the 92, 94% mark, which is much lower than what you would want to see. So right now we've identified that there's a problem with the fill ratios of a particular set of trades that are running off the data from Reuters, but we don't yet know what's causing this issue, but we can now start to investigate. So here we have an overview of the health and performance levels of the inbound data sources, aka the 2 market data feeds from our 2 vendors, Bloomberg and Reuters. At the top here, we've got the bandwidth saturation of the 2 pipes across our 2 vendors. Again, we want to ensure that it's not deviating too far from what's expected. Down here, we've also got the number of raw events coming into the trading infrastructure per second across our two vendors. But what we are interested in this case is the average latency of the inbound events. And you can see here that the data sources coming in from Reuters, the latency is significantly and consistently higher than the data sources coming in from Bloomberg. So let's drill down to get a more detailed look. So here we have a more focused view of the latency of the data sources from two market data vendors, and they're spanning across the last 5 minutes. And if you have a look at the y-axis here, you can see that the average latency for the Bloomberg data sources hangs around the 500 to 600,000 nanosecond mark, whereas for the Reuters data, it's around the 800 to the 900,000 nanosecond mark, which is quite slower than what you would expect. So let's drill down one last time. So this dashboard gives us a detailed look of the latency across our financial instruments. And you can see here that the Reuters in the green, the latency is significantly, is slower than the data coming in from Bloomberg across all our financial instruments. So now that we've, and obviously if we were a trading team in this situation, we would be able to locate the algorithms of the trade running off the Reuters data, replace it with the Bloomberg data, and until we fix the issue with Reuters, and then we'd be able to revert back. So now we've identified the reason for the dip in the fill ratios is due to an increased spike in latency for one of our market data vendors. We can move on to our IT ops dashboard and see if we can fault find exactly what is causing this issue. So this is our IT ops dashboard, and it gives us an overview of the health status of our co-location infrastructure. At the top here, we can see the health of our major network pipes. There are 4 outbound channels for the exchanges and the 2 inbound channels for the 2 market data providers. And typically you want to see a network utilization of close to 100%, but not over, as this can start to spike latency and start to slow down the trades. And actually you can see here that the Reuters channel is spiking periodically over 100%. And that's not something we want to see, and we'll investigate this quite shortly. Here we've got the clustered hosts across our 4 co-locations, and it's the live memory usage for these hosts. And we want to know this because these hosts are responsible for executing the trades. And again, if you see the live, if you see memory usage going over 100%, this can start to slow down the trades and so on. More critically, down here, we've got the aggregation of errors for the last 3 hours. And this is the aggregation of errors across our entire platform. So all the applications and infrastructure will be, you'll be able to see the errors pop up here. And this table here gives us a more detailed view as to what these errors actually are. And we'll come back to this table in a second. Down the bottom here, we also have the memory usage per host across all our exchanges, the disk usage percentage by host across all our exchanges. We've also got some live machine data. On the left here, we are essentially grouping for errors and warnings. And on the right, we've got security events, live security events on the right. So if we come back to this table and rank order these by frequency, we can see straight away that there is an error, there's an issue with with the incoming fiber channel. And this is probably the culprit that is causing the spike in latency for our Reuters data. So if we come to the search, I'm just going to type in fiber since that was the issue. And you can see straight away that there are a bunch of errors to do with initialization failure on a fiber channel adapter, and that error seems to be related to a storage syslog issue. And that's the end of the demo. And I just wanted to recap quickly that we noticed a drop in a particular set of trades, aka the fill ratio is dropping. It wasn't as high as we'd expected. And that was because an increase in latency for some of our inbound data sources. And we were able to pinpoint the exact reason for the increase in latency within a matter of minutes. Thanks. Oh, and if you have any questions, post them in the Q&A chat and I'll do my best to answer them. Thanks, Dave.
Thank you, Yushin. If you want to stop sharing there, that is
yep.
a fantastic project. Again, another really great example of what the Splunkterns have been doing. Actually, I've been getting some messages off the side here, some of them being next level awesome with being the Splunkterns, and another one asking to be a Splunkturn. Sorry, you're over 60. I don't think Neil's going to be letting you in the door. But honestly, there's some great stuff altogether. So I'm just going to share up the screen. Also, while I'm doing that at the moment, fantastic global collaboration from Yushin right across the business, dealing with people in the UK and the US in order to be able to get access to that data and get those ideas and sharing. So fantastic work. Okay, Andrew, this is over to you.
Awesome, thanks, Dave. Yes, it's my pleasure to introduce Chamat, our next intern. He's a final year student at Monash Uni, doing a double degree in mechanical engineering and actuarial studies. He's a recent convert to chess, which seems like a great fit for his kind of logical mind. And his project this afternoon is regards modelling passenger flow in transport networks. Over to you, Chamat.
Got to unmute myself first, but thanks, Andrew, and hey, everyone. Since Andrew has already given a quick introduction about me, let's get straight into my project. So as Andrew mentioned, my project is based around modeling passenger flow in transport networks by utilizing Splunk. And for this presentation, I'll give an introduction into what motivated me to do this project and why I pursued something in the area that I pursued. And then I'll give a quick description of what the problem is and why I think it's so important to solve. Then I'll do a quick demonstration on how I use Splunk to solve the problem. Cool, so as an introduction, let's begin at the beginning. So when I was first starting off my Splunk intern journey, I was very interested in a lot of the use cases that Splunk was being utilized for. And some of the stories that really stood out to me were the IoT data use cases. And having a mechanical engineering background, I could really see how I could use IoT data and Splunk in the future as a mechanical engineer. So I kind of want to explore that avenue in my project. And one of the things that really stood out to me in the first couple of weeks were how visually appealing the dashboards are in Splunk. And one aspect of that really stood out was the maps aspects. I've never seen data being summarized and presented on a map that's so visually appealing, and also was really easy to implement as well. So I kind of wanted to embody that in my project. And some of my personal goals was to use Splunk to solve a real life problem, and also develop my SPL skills so that I can create very visually pleasing dashboards. And one of the biggest other considerations was the ability to leverage my university knowledge. So I have a mechanical engineering background, and one of the hottest things in mechanical engineering right now is turbulent flow. And the reason it's so hot is you can't model turbulent flow using mathematical formulas. You actually need data from IoT sensors, and you need to model that data through some sort of machine. So I kind of wanted to explore IoT data just because I want to test my mechanical engineering degree. And on the other side of my degree, I have actuarial studies, which is a very statistics-based degree. And I wanted to massage that side of my brain. So I wanted to do something like a node diagram or create some algorithms that will really test my statistics background as well. And this led on to the problem that I wanted to solve. And the problem that I wanted to solve was that current traffic models may lack the ability to model passenger flow in a way that is practical and easy to digest. And by practical, what I mean is there is a lot of data that's available for passenger flow, but you need a platform or a machine to be able to crunch through that data and be able to produce statistics that can be easy to interpret. And it needs to be easy to interpret and also needs to be visually pleasing so that we can uncover stories from that data. And if you're not able to do this, this can lead to poor transport management because you're not able to understand how the communities are behaving and adapt to how they're behaving. So some of the business implications of this is that if you don't understand what's happening to your commuters, you're not able to adapt your network and you're not able to allocate your resources in a way that is efficient and cost effective. And this can also lead to limitation in adaptability when it comes to sanitation. Right now, with a lot of the cities opening up, making sure that areas where there is a lot of areas that have a lot of people need to be very clean. And we also need to ensure that those areas are also secure. And we also want to keep the trains running on time and ensure that there isn't too much congestion going on. And the reason why I thought this was a great problem to solve using Splunk is because Splunk is the universal machine data platform for crunching through data and allowing us to uncover stories. And once I create some dashboard, it allows me to get multiple lenses into what's happening in the train network. And it also allows us to uncover stories in real time as well. And if you have these dashboards up and running, it will allow for us to solve problems when issues do arise. And also we can do some investigations into it and try and put measures in place for the future in case something does go wrong. So that's a quick introduction of why I did the project and what can be done with the project. And I'll hand it off to Chamath from a couple of days ago to give you a quick demonstration of what I've been able to accomplish with Splunk. And
thank you to Chamath. I'll take over and give you a quick demonstration of what I've been able to create to solve the problem that I stated before. So I've created an application called the MyKey Activity Monitoring app, and this gives you multiple lenses into the transport network, and we'll get into one of the dashboards. So the main dashboard for this application is the train activity monitoring dashboard. This allows you to monitor the activity that's happening in the train network. And first of all, you're able to filter down by time. So for this little dashboard for now, it's under 1 day, and also allows you to filter down by direction to the city or from the city, and also allows you to filter down by different MyKey types as well, such as secondary school and concession type. But for the length of this demonstration, I will keep it to all MyKey types. So that brings us to this main and beautiful panel right here. So what this panel is doing is summarizing all the data of touch-ons for people that are traveling towards the city for this day. And it's calculated in ways such that red is indicating that it's a very active station, and green is indicating that it's not a very active station, whereas blue is indicating that there was no activity at all. So straight away, we can see where the hotspots are when it comes to train activity. We can see that Box Hill is one of the hottest areas with 4,700 passengers traveling towards the city. And also Corfu with 3,800 passengers traveling towards the city. And also South Yarra with 2,700 people traveling towards the city. And if you're familiar with Melbourne, you might have noticed that the city centre is missing out. And the reason for that is because the dashboard has a direction to the city or from the city. If you're traveling within the city, there is no direction to the city or from the city. So we isolated the city stations into different panels. And for this panel, we've combined all the stations as one station called the city. And the panels down here for each individual city station give you, first of all, a unique user count that allows you to identify which stations are very active and which ones are not. And you also get an activity counter on the bottom where touch-ons and touch-offs are occurring and when they're occurring as well. And one of the things that really stands out to me quickly are the two weird peaks that are happening at Southern Cross Station. So you can see a peak of touch-offs occurring at 4 p.m. So people are arriving at Southern Cross and touching off, and then people are touching back on at around 7 o'clock and getting on these trains to go outwards from the city. And if you do some further investigation, you'll find out that there was actually a football match occurring between Essendon and St Kilda at Etihad Stadium, which is right next to Southern Cross. And that game went from 4:30 until 6:30, which actually correlates with the two peaks that we have right here. And why this is important is if you have this data coming in real time, you will notice that there was a trend of a lot of passengers getting off at Southern Cross around 3 o'clock. And once you identify this trend going up, what you can do is you can deploy your sanitation resources and your safety resources to ensure that passengers, when they do get off Southern Cross, are greeted by a clean environment and it's very orderly and there is security in place to ensure that they're secure. And another thing we can do with this dashboard is that we can do further investigation. So we notice that there's a peak of people touching on the Southern Cross at around 7 o'clock. So one of the questions I have now is, where are these people going after the game? So to do that, we can use the top panel up here. So what we want to do is we want to filter down by time. So the match finished at 6:30. So we want to filter it down to around 6:30 till 8 o'clock, which I've already opened up in a different tab. So between 6:20 p.m. and also 8 p.m. And we're also looking at a direction of from the city, since we've investigated people that are traveling outwards from the city. And straight away, we can see that 2,500 people are traveling towards the southeast regions, and not many people are actually traveling towards the northeast regions. And there's only 700 people doing that, and 1,600 people are traveling to the northwest regions. And with this information, what we can do is, if there is another match at Etihad Stadium in the future, we can put in place more trains at Southern Cross, such that commuters are able to travel towards the southeast regions and northwest regions in a manner that is not as congested, and keep that area sanitated, and also make sure the area is dealt with in an orderly fashion as well. So that's just an example of how we can optimize the network to be better and more efficient, and also make commuters' behavior by using this dashboard. So the panels down here allow you to be reactive towards what's happening in the city stations, whereas the panel up here allows you to investigate and be proactive and put in place measures in the future by doing investigations with the data that you have right now. And you can do a lot more with this dashboard. And one thing you can do is, we noted that earlier that South Yarra was a hotspot for people traveling towards the city. And I just want to highlight that I've gone back to the original settings of looking at a day, and we're looking at direction to the city. And once again, South Yarra is a hotspot. So maybe you want to know what's happening in South Yarra. Can we do something with South Yarra to make it less congested? So if we double click into South Yarra, it brings up these panels down here. And this panel up here brings all stations that are on the same line as South Yarra. And we can see straight away that between the city and Dandenong, and also between the city and Sandringham, it's actually very busy. And once we identify this, we can put in place more trains on these lines, and we can make these trains travel between only the hotspots of city to Sandringham and from the city to Dandenong. And we can have those trains skip past stations that are less active, such as Yarraman and Melbourne. So we can put in place limited express trains to ease congestion and makes the commuters happier. So that's just another example of how we can optimize the network and make commuters happier while making the system overall more efficient as well. And you can actually do a lot more with this dashboard, but that's just quick examples of what can be done with this dashboard. Cool, and this brings us to our second dashboard, which is a public transport monitoring dashboard. This allows you to filter down by a particular mode of transport. In this scenario, we're looking at bus activity, and this panel right here allows you to identify how the activity trends over time and where it's occurring and when the hotspots are occurring as well. And if you give it a quick play, you're able to identify where the hotspots are. So we can see at around midnight, it's not very active, and the city is kind of active. And as it gets later on at night, around 1 a.m. and 2 a.m., it's getting almost completely dead. And we can see that it picks up on activity around 5:30, when people are starting to go to work, and it really starts to pick up, and when people are arriving, it starts to die down after arriving, and around lunchtime, it starts to pick up again. Dies down and picks back up again when people are going back home. And one of the things that stood out to me was that the Box Hill region and also the Dandenong and Melbourne Centre is one of the most active stations, one of the most active regions in Melbourne when it comes to bus activity. So we play it through, we can see that it slowly starts to die down. By midnight, everything is back to being completely dark. And one of the things that really stood out to me was one of my most common stops that I go to is the Monash University bus stop. And it was actually very cool to see that it's actually the second most active bus stops, which I never would have known unless I had this dashboard. So this leaves us with our final dashboard, which is the most active user dashboard. And I think this dashboard is very important because when you have users that are using their MyKey a lot, this normally indicates that first of all, that they might be up to something no good, or that they don't really know what's happening with the network and maybe need some guidance. And a prime example of this is the person with the most touch-ons for this day. This person has 63 touch-ons, and we can see that this person held a card indicating that they have a disability. And looking at their journeys, we can see that they've made 2 different journeys, and those journeys from the city towards about Dandenong they have touched on and touched off multiple times, which is really odd. And looking at our activity counter over here, we can see that they've touched on and touched off for 18 different journeys, which in a 4-hour period. This indicates to me that they might not be well informed of how the transport network knows, how the transport network works. So if we had this data come in real time, we will be able to identify that something was going wrong with this person around here. Then we will be able to send out some of our team to be able to go and talk to him and maybe offer him some guidance, such that they weren't touching off and touching on so many times to go to a destination. And another example of this is if we drill down into the second highest count of monthly activity count. And by drilling down here, we can see first of all that this is an elderly person. And they've touched on and touched off only at Melbourne Central Station from the looks of it. And we can also see that from 5 a.m., that all this activity has occurred from 5 a.m. to 6 a.m. And they've touched on and touched off 27 different times. This indicates to me that they don't really know what's going on. Maybe they need some help. And once again, if we had this coming in real time, we'll be able to send someone out to go assist them and maybe offer them some guidance on how to get home. So that's just another way of uncovering stories and making commuters' lives better. So as a whole, this application allows you to get insights into the transport network, allows you to do investigations and also use real-time data to make commuters happier and be able to guide them a lot better. And that's it for the demo, and I'll pass it back. Thanks.
Yeah, cool. Thanks, Chamath, from a couple of days ago. Yeah, so there's actually quite a few improvements that could be made to the dashboard. I actually wanted to add a lot more dashboards into it. I could actually take a lot of inspiration from Edlin and maybe get some train maintenance data in there as well. But there's a lot that could be improved. And yeah, and before I end, I want to give a huge shout out to Matt, who has really helped me with this project. And I'll end it on that. Thanks.
Awesome work. That's fantastic, Chamath. I'm actually getting messages here as well, just saying about tell these Splunkterns stop, they're blowing my mind. So we can take it a bit handier on them, that would be good. Also, great job, Chamath, in introducing us to time travel in one of our user groups. That's something new for us. So now, Andrew, over to yourself.
Thanks, Dave. We have our final intern for this afternoon, young Amy. Now, Amy moved to Melbourne from her hometown of Brisbane at the tender age of 17 to undertake studies at Melbourne University. In fact, a double degree, computing and software systems, along with Japanese. And very pleased to say that 3 days ago, Amy successfully graduated. So congratulations, Amy. That's awesome achievement. She's quite the creative and a security nerd as well. And appropriately, her project this afternoon concerns honeypot. So over to you, Amy.
Yep, thanks so much for that, Footy. I'm just going to go share my screen. Get that PowerPoint. Share that. Perfect. Let's hide that. Beautiful. Okay, so my project today I'm going to be talking about is my integrating Teapot with Splunk. And oops. Next slide. Cool. So this page is chaotic. I put it there as my introduction slide. I think it represents me in terms of just really unorganized and a bit completely unorganized, and just I like art, very artistic, so I definitely put that a lot into my project. Now, you might be asking, what is Teapot? Didn't you say honeypot? That's in your title, Teapot. But before that, I will explain what a honeypot is. So a honeypot essentially is a trap for cyber attackers. What it is a system that lures attackers by mimicking a real life system, so that it basically diverts the attacker's attention from the system, the real system, to the fake system. And by doing that, it can detect the attacks, and it can also monitor the attacks. And yeah, so it's an extremely useful resource for protecting actual networks. I thought it would be a great idea to get this data from a honeypot and implement it into Splunk. If a honeypot were to detect and deflect, then I thought Splunk might be a great option to be able to dissect the actual information. So I put that straight in there, and yeah, I chose a honeypot project because it's really exciting. There's lots of potential uses for the data and lots of types of honeypots out there, like ones for malware, spam, network, and even individuals attacking directly into the networks. So I'll go into the next slide. And this brings us to what is Teapot. A teapot is a platform where it integrates lots of different kinds of honeypots, all manner of honeypots, into one single platform. Each of the honeypots are Dockerized images of the honeypots themselves, and it just gets all the data in all at once. So the next question is, why would I want to implement it in Splunk? Why Splunk specifically? So the main reason I chose Splunk was I thought it was a good idea as because Teapot gets so many data from so many different locations, and because the different data comes in different formats, Splunk is basically made for that kind of data. So I thought Teapot and Splunk really complemented themselves really well, and it would be good for that kind of thing. But not only that, I could also do flexible custom dashboards as well when I feel like it. And also the additional bonus of being able to utilize something like Phantom, where I can detect and automate certain activities. Like some examples that I managed to, that I thought up and discussed with some people at Splunk were, for example, being able to, if you implement the honeypot with automation, you can actually detect, you can have a list of the attacker IPs, put certain IPs on blacklists depending on what they've actually done. You can also validate the source IP and immediately kick them off as soon as it's not validated when you find out that IP isn't validated specifically. And you can also create like a scoring mechanism by using machine learning to slowly like figure out which attackers are more prone to actually get further in and what movement they do. And then from there, you can actually have a scoring mechanism, make blacklists, and also just cut IPs out completely, or else detect what the attacker is doing inside the system, and then cut them off once they hit a certain point that that basically the automation of Phantom is able to do. So I personally thought that it would be an extremely interesting part where with lots of potential for exciting projects. So I definitely decided to delve straight into that. Now, next. So now I'll move on to what I learned from my actual project and what I actually did. So move on. I found out that the internet is very helpful. As you can see, there's a lot of helpful responses here, and no matter how much I researched, I just couldn't find straight answers, and all the topics that I wanted to search for were just, for some reason, not talked about. I found it very odd that even though Teapot complemented Splunk very well, in my personal opinion, I couldn't find much information. So yeah, I learned that real-world projects are challenging and unpredictable. There's lots of unexpected errors, lots of dead ends, rabbit holes, poor documentation all over the place, and eats up a lot of your time, especially when you're exploring a field where first steps aren't even documented. And that's pretty much, I found I was trying to do the first steps for the longest time and I just couldn't get through it. So that was one of the hardest bits, definitely. And as I said here, the scope of what I can do within a given time frame is very limited. So in terms of my next steps, future plans, definitely work on implementing these extension ideas. I would love to kind of delve straight into actually being able to use all these extended ideas that you can think of with this potential and just see how it goes. But the problem is there's lots of ideas out there. There's lots of things you could possibly do with this information, but I can't really do it by myself. So I definitely think the next plan is to make my experience and findings and methodology public, to be able to facilitate others' time, to be able to spend that time innovating and experimenting with the actual data. And that way they'd be able to skip those basic steps, get through it all with the similar implementation and get that data and use their own ideas and innovations to just play and have fun with the data. So I think that's definitely definitely something that I would like to do, write a blog and try my best to do that and post it. Cool. So very short presentation, but I just want a special thanks to Mickey, James, Matt, Ryan, who gave me all these ideas about what I could possibly do, helped me out with so many of the little things that I couldn't figure out, and an extra special thanks to Footy for like just supporting me throughout this whole journey and just debugging all my mistakes because I had a lot of them. So yeah, thank you so much for watching. It's all right.
Awesome job, Amy. That's fantastic. Great altogether. I also do want to call out the extra help that all our Splunkterns got from our previous Splunkterns that are with us today. So Byron, Kelsey, Phoebe have been fantastic in supporting all of them, which is fantastic. And with that, that's the end of the sessions that we have here. But what we want to do is open it up to any of the participants. If you've got questions or thoughts, anything that you want to be able to share. So you can raise your hand. I'm not sure how that's going to go when we start searching. I'll be looking for the rest of the panelists to help here. And in the absence of having any questions just yet, I'm going to put it out to the Splunkterns. What did you think of your Splunkturn experience?
I'm just going to quickly refer to one of the Q&A questions, but
Great.
I shared my LinkedIn link at the start of the slide, but my name is Amy Nightingale. So if you do want to contact me in helping me work on this and carry on making it, that would be absolutely wonderful. But yeah, yep. And to start off with my Splunkturn experience, absolutely great. I really enjoyed the people and I think they helped me significantly throughout. And yeah, I mean, it's something I'm very passionate about. So I thought it was absolutely wonderful that I had other people around me who was passionate about similar things and just could help me along. And it was, yeah, I very much enjoyed it. Thank you. Thanks, David.
Neil is watching, by the way, so we let's be careful. How did you find going from 0 to hero with Splunk, given the short span of time that you guys were with us? If somebody wants, Edlin?
I think in the beginning, like even before I started the internship, like before I started like the first week, I was full like freaking out because I remember like downloading and like doing the fundamentals course. I was like, oh my God, there's like so much stuff to learn and so much stuff to do. And then I was like freaking out. But I think along the way, especially with the help of all the mentors like yourself and everyone around me and all the online documentation, has been a really great help to go step by step in building up the project, or even helping out with like some of the proof of concepts with the other sales engineers. Yeah, there's definitely a lot more I need to learn, but I think like, especially during the times where I'm stuck on something and seeing the light of that solution of how I could do it, I think that's the biggest part in my learning experience in improving my skills.
Very good. Yushin, for yourself, with regards to collaborating, given the fact that you had a lot of experience going across, what did you think of that as an experience, dealing with other people in different time zones?
Yeah, it took me by surprise actually, because when I reached out to Hader and you know, I reached out to work with him, I thought he would just turn around and be like, no, I'm not working with an intern, like that wastes my time. But yeah, I was surprised. He was like, yep, I'd be very keen to work with you. And he had an interesting project ready to go. So yeah, I had an awesome time. And like, it wasn't just Hader, so we linked up with like a bunch of the, like, I suppose the FSI experts within and outside of Splunk to sort of give input for the project. So that was a lot of fun.
Cool. There's a question coming here, Chamet, that we can direct towards yourself. What's been your favorite part of the Splunk portfolio?
Oh, the Splunk portfolio. I think, like for me, I come from a very different background to like computer science. So I got a lot of experience in something which I never even dreamed about. And I think just the whole experience as a whole, like I'm learning something new every single day. There were a lot of challenges, but I had Matt and everyone being very supportive, and I would get a lot of feedback, and I was able to like improve from that. I don't know if that's a direct answer to the question, but that's one of the things I loved about the internship.
Excellent. John, for you, how difficult was it to work with your mentor?
It's very difficult. Not kidding. It was great. I think Dean overall helped a lot. He always tried to give me some exposure to his customers. Potentially that could help me in terms of like future career perspective. I think overall, and he helped me a lot on the project as well, in terms like answer a lot of like questions, whether it's like technical and interpersonal.
So very difficult. Thank you, John.
Yeah, very difficult.
And did you have fun, everybody?
Yeah, definitely.
Yeah,
yes, for sure.
Well, given the fact that we're up until that time, we don't have questions coming up. I'd like to thank everybody that's participated and joined us today. I hope you found it as inspiring as we find it, looking at these Splunkterns and seeing what they've been able to get out the door with such short time, and a lot of focus, a lot of energy, and a lot of passion. Thank you very much, Neil, for running the program. It's something that reaps benefits every year, year in, year out. And thank you very much, Splunkterns. You are always going to be part of this Splunk community. And with that, thank you very much, everybody. Stay safe no matter where you are.
Thanks, David.
Yeah.
Thank you.
Bye.
Thanks, Dave.